In these videos, we are going to discuss many examples which have many important ideas in algebra. Let's start by number one. First exercise says the two roots of the equation x power 2 minus 2 root 5x plus 1 equals 0 are the two roots are real rational or not real or equal real or real irrational numbers. First, we have to say that uh, when you are talking about the quadratic equation, if all coefficients are rational numbers, and this discriminant also is a perfect square, you can say that the two roots of the equation, two roots are rational numbers. But if all coefficients not rational numbers, if all coefficients are not rational numbers, and discriminant is perfect square, the two roots are real irrational. Let's start here. X power 2 minus 2 root 5 plus 1 equals 0. A with coefficient of x power 2, a equals 1, b equals negative 2 root 5, and c equals 1. Discriminant equals b squared minus 4ac equals negative 2 root 5 power 2 minus 4 times a times c. A equals 1 and c equals 1. Negative 2 root 5 all power 2 equals 20. 20 minus 4 equals 16. And we know that 16 is a perfect square, as we can write 16 as 4 power 2. Or you can say that 16 has a square root. Here we know that the discriminant is a perfect square. Discriminant perfect square. Perfect. But all coefficients are not a rational number because 2 root 5 is not rational. Here we can say that the two roots are real irrational numbers. The right answer will be number 4. Number 4 is right. Find the interval in which the constant a makes the roots of the equation a plus 2 x power 2 plus 2x plus 3 times x plus a minus 1 equals 0 are not complex. We know that if the discriminant greater than 0, the two roots are different reals. But if discriminant equals 0, there are two equal real roots. If discriminant is negative or smaller than 0, that means that the two roots are complex. Here we need the value of a, which makes the two roots are not complex. Not complex may be different real or different or equal real. We can write here the discriminant greater than or equal 0 because they may be different real or equal real. Discriminant greater than or equal 0, b squared minus 4ac greater than or equal 0. B squared, b is a coefficient of x, 2a plus 3 all power 2 minus 4a coefficient of x power 2, a plus 2 times c. C is the absolute term, a minus 1, all of these greater than or equals 0. 2a plus 3 all power 2, first power 2 equals 4a power 2, second power 2 equals 9, first by second by 2, first by second 2a times 3, 6a times 2, 12a, negative 4, we will multiply a plus 2 and a minus 1. First by first, a times a power 2. Second by second, 2 times negative 1 equals negative 2. To find or to calculate the middle term means and extremes means a times negative 1 equals negative a, 2 times a equals 2a. We add negative a plus 2a equals 1a. Here the middle term is positive 1a. Can we cancel 1? We can write a power 2 plus a minus 2. All of this greater than or equals 0. Next step, 4a power 2 plus 9 plus 12a, negative 4 times a power 2, negative 4a power 2, negative 4 times a equals negative 4a, negative 4 times negative 2 equals 8, greater than or equals 0. 4a power 2 minus 4a power 2 equals 0. 9, what about a? 12a minus 4a equals 8a. 9 plus 8 equals 17, greater than or equals 0. 8a greater than or equals 17 will we will move 17 on the other side. 17 will be negative 17. We will divide by 8. A greater than or equals, here divided by 8, greater than or equals negative 17 over a. A greater than or equal negative 17 over a. That means that all real numbers are greater than or equal negative 17 over a. We can express the values of a as an interval. A belongs to closed interval negative 17 over a and infinity. In this exercise, if the roots of the equation x power 2 plus b x power 2 plus b equals 0 are different reals, if the roots are different reals, that means that ab greater than 0 or ab equal 0 or ab smaller than or equal smaller than 0, choose. Can we find the discriminant of this equation? To find the discriminant equals b squared minus 4ac. Here a equals a, coefficient of x power 2, b coefficient of x equals 0. Here there is no term of x. Here c equals b. A coefficient of x power 2, b coefficient of x, c is the absolute term. Discriminant b square minus 4ac, b square equals 0 power 2 minus 4 times a times c equals b equals negative 4ac, equal negative 4ac. But here we say that the roots are different reals. If the roots are different reals, that means that the discriminant greater than 0. Here discriminant greater than 0, greater than 0, negative 4ac greater than 0. We can divide by negative 4. Here divide by negative 4. AC, if you divide by negative, you can change the direction of the sign. Greater than, it will be smaller than 0. Here AC smaller than 0. AC smaller than 0. Sorry, here A, B, we can write here as B, negative 4AB. C, we can write C as B. AB smaller than 0. AB smaller than 0, the third choose. discriminant if the two roots are different reals. If the two roots are different reals, that means that the discriminant greater than or equal 0. B square minus 4ac greater than 0. 0 minus 4 times a times c. A here equals a, and c equals b. Negative 4ab greater than 0 divided by negative 4. That means that ab change greater than will be smaller than ab smaller than 0. Next. If the equation x power 2 minus 2 root x power 2 minus 2 root x plus a has two conjugate complex roots. If the equation x power 2 minus 2 root x plus a has two conjugate complex roots, can you find the values of a? We can say if roots are conjugate complex, that means that discriminant b square minus 4ac smaller than or equal 0. If the roots of the equation are conjugate complex, put discriminant b square minus 4ac smaller than or equal 0. B square minus 4ac smaller than or equal 0. Here a equals 1, b equals negative 2 root 2, c equals a, b square negative 2 root 2 power 2 minus 4 a 1 c a, all of these smaller than or equal 0. Negative 2 root 2 all power 2 equals 8. 8 minus 4a smaller than or equal 0. 8 smaller than or equal 4a. We can divide by 4. A 8 divided 4 equals 2. We can write it as a greater than or equal to. That means that the values of a belong to all real numbers here greater than or equal to a greater than or equal to all real numbers greater than or equal to the closed interval to an infinity. Closed interval to an infinity, the last one. The opposite curve represents the quadratic equation y equal ax power 2 plus bx plus c. Which of the following is correct? Which of the following is correct? If you look to the opposite curve, you see that the curve open downwards. And I think that all of us know that if the curve open upwards, that means that a which represents coefficient of x power 2, a greater than 0. If the curve open downwards, that means that a smaller than 0. Here, the green curve represents downwards. That means that a smaller than 0. A smaller than 0, A1 refused, number 1 refused. Here A smaller than 0, number 1, A greater than 0 refused, and also number 2 refused. What about number 3 and number 4? Here A negative and A negative. Look again to the curve. The curve here cut a positive part from y-axis. Again, the curve cut a positive part from y-axis. That means that c greater than 0. C is a positive. Number 3. Find the values of k which satisfy the equation k minus 1 times x power 2 minus 2k times x plus k equals 0, which makes the equation has no real roots. Has no real roots means that two complex roots. Two complex roots, discriminant smaller than 0, b square minus 4ac smaller than 0. Here a equals k minus 1, b equals negative 2k, c equals k. Uh, b square minus 4ac, b negative 2k power 2 minus 4 a k minus 1 times c k, all of these smaller than 0. Negative 4k all power 2 equals 4k power 2, 4k power 2 minus 4. We can multiply 4 and k first. 4 times k equals 4k times k minus 1 smaller than 0. 4k power 2 minus, can we times 4k, can we multiply 4k by the bracket? Yes, negative 4k times k negative 4k power 2, negative 4k times negative 4k times negative 1 equals positive 4k smaller than 0. 4k power 2 minus 4k power 2 equals 0. We cancel this with this. We have 4k smaller than 0, divide by 4. 4 divided 4 1, 1k smaller than 0 divided 4 equals 0. K smaller than 0, we can write k belongs the interval all of real numbers is smaller than 0 from negative infinity to 0 open.